Hello everyone, I'm Afshan Anjumbaba, a PhD scholar from Kashmir. I'm going to present our work on Kashmiri Hamam, an exploration of technical design within traditional architecture and culture, along with my co-presenter Mahshida Hamid. Now, home heating in Kashmir. Home heating in Kashmir is usually needed because of the fact that the temperatures in the Kashmir Valley are so low, even sub-zero at times. The modern houses in Kashmir need more substantial heating for indoors than the traditional ones due to high cost and unreliability of electricity and gas. Many Kashmiri families rely on firewood for home heating. Now, traditional houses in Kashmir were usually built from bricks, mud, and wood with lesser number of windows and doors. The walls were usually mud plastered and houses faced south, which would make these houses insulated. On the other hand, the modern houses are built from cement, steel, boundaries, and high ceilings, which makes these houses poorly insulated. There are some other alternatives of heating too, like kangri, bukharis, wo- woolen blankets, woolen clothes, etc. Now, an introduction into hammam. Hammam is commonly known as Turkish bath, comes from word hamma, which means to heat up. It is considered to be the Turkish origin and believed to be introduced by Mughals in Kashmiri architecture. Earliest hammam introduced by Mughals in Srinagar dates back to 17th century. There are some pictures where older men can be seen warming up themselves in community hammams attached to a mosque and a fully furnished hammam of a family. Now, a hammam is a room in which thick hand-carved rectangular slabs of limestone are laid over hollowed out floor. As can be seen in the picture, limestone slabs are supported by columns of bricks at the joints bound together with cement. The inside walls of the hammam are lined with bricks sealed with the lime mortar. The floor is scattered with sand, bits of glass, and boulders to absorb and retain heat. Firewood is placed in the hammam through a small door. The smoke escapes through the chimney that goes right up to the roof through all the levels of the house. Some people are some people even use water tanks above the furnaces to ensure hot water supply in winters. Now, the project objectives were we applied a mixed social and engineering research method approach to understand the needs of and the preferences of the hammam users in Kashmir and evaluate the thermal performance of a typical hammam.
Hi everyone, I'm Mahshida Hamid and I'm a mechanical undergrad. I recently graduated. So now our work relied on methodology, which involved mixed method data collection. The first method was surveying. The first important thing was surveying the hammam households and the constructor who builds the hammam. The total number of household participants were 12. As you can see in the pictures, there is a household survey ongoing with a lady. Then there is an hammam inspection, and then there is another household interaction. So after the surveying, what we got wonderful insights from the survey. As you can see the picture, there is the hammam which is under construction. You can see the limestone being created on the boulders and joined by cement. Then we went to the hammam limestones which are made in the central Kashmir. So after that, there is a furnace opening through which the wood fire we burn is initiated, and the fire spreads throughout the hammam floor and warms up the people that sit on the floor. Then there is a picture of hammam household interaction, and then there is a picture of a hammam furnace which is covered by soot because of the fire. There were some energy consumption insights we definitely got from interviewing the hammam households. The first was the average fuel consumption in kg per day was 14.56 kgs per day. The cost of operating hammam over winter season was around 30,000 INR, which is around 428.5 US dollars. The cost of construction ranged from around 40,000 to 80,000 rupees INR, which summed up to 571 to 1142 US dollars. The cost of carpets, which are kept on the hammam floor, ranged from around 10,000 to 13,000 INR. The cost of woodwork, the paneling work that's done in the hammam, ranged from around 10,000 to 25,000 INR. After that, there is a cost of LPG, which is used for cooking food. It's 800 INR for 14.2 kgs of LPG gas for a single month. Then there was the cost of electricity, which ranged from around 800 to 3,000 INR. After that, what we got is we got some specific household surveys. The first thing what we got was the placement of hammam, which is an important factor in regards to the house and the outside environment. And what we deduced from it was most of the people preferred the placement of hammam to be in the outside air. Then there were improvements in hammam. Several households shared their ideas and interest in participating in future design improvements. A few of them suggested about the ventilation. Some of them suggested about window improvements, and many other gave certain answers. But most of them were satisfied in way hammam is constructed and hammam is. Now, after that, there is an important thing in hammam, which is the firewood consumption. The different types of firewood that are used are Kashmiri kicker wood, which is the most common being. Then there is walnut, then there is mulberry and apple. Several hundred kgs are consumed per winter. So after that, there was a physical measurement setup that we created. It was a real-time temperature and humidity analysis. The temperature, we used two temperature sensors, which were DS18, B20 sensors. One was placed in the hammam wall, the other was placed in the hammam floor. There was a DHT 2022 temperature and humidity sensor, which measured the temperature and the humidity of the hammam. This was a setup installation that we did, and this is a temperature and humidity data logger setup. The duration of the physical measurements that we took was around 1 month. After that, the data that we got from physical measurements suggested this graph. We created this graph. It suggested that the outside and inside air of the hammam were analyzed for 1 month. And the graph shows that the temperature curves of hammam floor for 3 consecutive days, and the blue dot represents the firewood installation. After that, there were simulations that were conducted in MATLAB Simscape, and a thermal model of the hammam was created. As you can see, this blue represents the firewood opening, furnace opening. This is a hollow where the air goes and it warms up the people. So this was the basic thermal model of the hammam. And after that, what we did is we compared the two measured results and the simulated results. As you can see, the green represents the floor temperature, which is the measured, and the red represents the inside temperature, which is measured. Then there is the purple one represents the floor temperature, which is simulated, and the black represents the inside temperature, which is simulated. So we can see there is not a lot of disturbance in our graphs. So this is another of our modeling results where we plotted the temperature, floor temperature, and the inside temperature in Kelvins. So what were the outcomes of our project were the future hammam designs should focus more on safety factors, as most of them suggested for ventilation, and some of them suggested window improvements, which resulted in proper ventilation. The overall efficiency can be increased by inculcating some improvements in the design, enhancing utilization of hammam according to the floor temperature. What are the next steps that would include in our data would be collecting more experimental data, more household surveys, utilization of more surveys to better understand hammam gases, like hammam ventilation and hammam buildup of gases. Then there would be also analyzing due to soot marks from the hammam use. So this is our team Kashmiri Hammam. It's Sabahat, it's Mahshida, it's Parth, Afshan, Professor Asad, and Professor Dan. So this is our team, and thanks a lot. And feel free to contact us. We can be reached at hamam@mit.edu. Thanks a lot. Thank you.